All right, so we are continuing with our little adventure on writing functions describing real-world problems. So this is day 2 of D. Learning goals. I can write a function rule given information in a real-world setting and use that function to determine additional information. And write a function that represents information given in a diagram. Simple enough, pretty straightforward. So we have Morty Car Rental charges $42 per day to rent a car. To rent a car, each driver must pay a $27 insurance fee. So we need to write a function rule for the total cost for N days of renting a car, including the insurance fee. All right, so the cost we are going to say is C. Okay, N days. So that sounds like something that's that's obviously a variable. So let's go up on our equation. We've got 42, and that's per day. Remember how I said to look for that word per. So that means that this number is going with this variable, and we said that day is a variable because it's n. So 42n, which leaves us with a flat fee that we can't help but pay and must pay, and it never changes. It's constant, and that's plus 27. So that's our function rule. Now we need to know, we're going to take this function and we're going to find out if a 2-day rental will cost half as much as a 4-day rental. So all we have to do is plug in, because so what we're solving for is this. And what we're going to do is we're going to say, okay, so here's our 2-day rental. N is the number of days, remember. So we're going to take 2 and plug it in for that, which gives us 42 times 2 plus 27, which is 84 plus 27, which is 111. So it's $111. All right, so that's 2 days. 4 days, 42 times 4 plus 27, which is 168 plus 27, which is $195. So 195 divided by 2 does not equal 111. Since this is not half of this, the answer is no. 111 is not half of 195. And this is just, you don't have to put this in there, but it helps. Half would be 9750. So if you took 195 divided by 2, it would be 9750. So that's really all you have to do is that's why getting this formula is so important, because if you don't get this right, this part right here is going to be a little bit difficult to pull off. All right, second and last example. So we need to write a function rule for the number of toothpicks in terms of figures. So the toothpicks are y, so the number of toothpicks is y. That's our y value. And the figure number, this part right here, that's our x value. So figure that's 2, 3. All right. And we can count. So like we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 toothpicks here. Here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We're going to stop right there. All right, so now we have 2 of them that we know the number of toothpicks. We know the figure numbers. First thing we want to figure out, though, is the slope. So now we have, so remember, this is y. So y2 minus y1. So I'm going to do 13 minus 20. Okay, over 1 minus 2, because this is our figure number. So it told us that these were our x's. For y's, all you have to do is count, okay? Count the number of toothpicks. It's as simple as that. And from that, we get our slope, which is negative 7 over negative 1, or just 7. So we know that that's 7x. Now, what we need to do is we need to find our b, which is 6. Well, you might be asking, well, how in the heck did you get that? Okay, so if this is figure 1, we got to imagine a figure 0, because remember, x has to equal 0 for this number here. So to do that, remember we figured out that this was the number of toothpicks was going up by 7 each time, which means if we go this way, we would have had to have added 7 to get this. And this number was 13, right? So b plus 7 equals 13. Well, if you figure that out, b equals 6, which is how I got that. All right, so I imagine that part there might be some questions on there. So if you're not sure and we don't, for whatever reason, get around to covering it as a class, come see me and I'll explain it to you. And that's it. All right, thank you guys. Almost done with this unit. Only 2 more videos to go. So